Discrete Fourier transform. In this chapter, we'll discuss about computations in DFT. Discuss matrix representation of DFT and IDFT equation. Let's take one example. X of n equal to 1, 2, 3, 4. By DFT, x of k equal to summation of x of n wn raised to nk. Expand this summation term. Now in this expression, there are only three different terms. One is x of k, x of n and w term. So let's take one matrix for output, one matrix for input. Here input matrix is x of n matrix, output matrix is x of k matrix, and this matrix will call it DFT matrix. Input values are x of 0, x of 1, x of 2 and x of 3. Here we have to write x of 0, x of 1, x of 2 and x of 3. Here we'll write only Tweedle factor, that is w term. So put k equal to 0, you will get x of 0. This x of 0 equal to small x of 0, which is already written here, multiplied by wn raised to 0. So here I'll write wn raised to 0. Then wn raised to k is 0. wn raised to 2k, k is 0. wn raised to 3k, k is 0. All w terms, wn raised to 0 will come here. Row multiplied by this column, resultant value is x of 0. Similarly, to find next value of x of k, put k equal to 1. When k is 1, you will get x of 1 here. That is equal to this x of 0 multiplied by wn raised to 0. X of 1 multiplied by wn raised to k, but k is 1. So here it will come wn raised to 1. X of 2 multiplied by wn raised to 2. X of 3 multiplied by wn raised to 3. Similarly, when k is 2, we get x of 2. Only w terms when k is 2. 0, 2, 4, 6. K is 3, x of 3. W terms with k equal to 3. So here, in this line, in this row, starting from 0 power, 0 difference in power. Starting from 0 power, 1 difference in power. 2 difference in power. 3 difference in power. This matrix is called DFT matrix. Now in this matrix, we'll substitute values of Tweedle factor by referring this circle diagram. First row is wn is to 0, that all values are 1. This is wn is to 0, wn is to 1, wn is to 2, wn is to 3. That means you have to go clockwise and write all the values. 1 minus j minus 1 minus 1. W is to 0 is 1, W is to 2 is minus 1, W is to 4 is 1, and so on. Similarly, input is 1, 2, 3, 4. Row multiplied by column. 1 into 1, 1 into 2, 1 into 3, 1 into 4, you'll get this. Next row, 1 into 1, minus j into 2, minus 1 into 3, j into 4, row multiplied by column. Addition of all these numbers will get required value of x of k. First value at k equal to 0, then next value at k equal to 1, k equal to 2, and so on. This is x of k. This is final answer. Now let's take another example. X of n is 1, 2, 3, 2. By discrete Fourier transform, by formula, convert this into matrix form, Tweedle factors, substitute values of Tweedle factors, substitute value of input, row multiplied by column, matrix multiplication, and then final answer 8 minus 2, 0 minus 2. Because n equal to 4, we can use this matrix operation. All Tweedle terms with negated power. It's the same matrix, DFT matrix, only difference is power is negated. To find its negative power of Twiddle factor, we have to go anti-clockwise direction. W is to 0 is 1, so first row will be 1. Second row is go anti-clockwise direction, 1j minus 1 minus j, 1j minus 1 minus j. Similarly, we have to write appropriate value of Twiddle factor, multiplied by x of k, divide by 4, you will get a required answer x of n. This is IDFT matrix. So whenever this n is 4, DFT as well as IDFT matrix is 4 by 4 matrix. If n is 8, the matrix size will become 8 by 8 and it will be very tedious to calculate. Therefore, matrix representation is recommended only for n equal to 4 and not for any other value of n. For any other value of n, we have to evaluate this equation and get the required value of x of k. Thank you.